I hope you are having display of the screen, and yes. Yeah. So in the previous discussions, we had seen this slide where wireless sensor networks, where what you can say definition here, you can say this is the definition. This comes for 2 marks. Okay, network that consists of sensors which are distributed in ad hoc manner, ad hoc word in a way that it is actually temporary. Okay, temporary, and when these networks actually, when these sensors are connected to mobile and mobile towers, mobile kind of communication network, and they move, it comes in this minutes. Okay, minutes. So then there was a next slide here, you can see where comparison with ad hoc networks. So these ad hoc networks might be mobile or another types of network. So we have discussed this thing. Let us what I can say briefly go through this. So this ad hoc networks and mobile ad hoc network. So when actually we have this IoE, here we say that this mobile ad hoc network mandates are there. So that is very important, because actually when we are going to deploy, mainly this IoT deployment, IoE deployment, they will be in what you can say mobile, in connection with the mobile networks only. So yes, wireless sensor network WSNs, they use the broadcast communication, while ad hoc network use point to point. So this is one change. We have discussed this thing that what happens that these sensors are there, and these sensors, they sense the environment, convert that environment into what you can say digital quantity numbers, and then this, they pass this on to what you can say the edge device, or you can say that gateway device, okay, or coordinating device. So there is one device which will actually communicate with all the sensors, or maybe the reader, and this so every time it may not be reader like RFID, no, RFID has reader, but in case of wireless sensor, this WSN deployment, it may be what you can say what you can say gateway device, and that device will be having all the communication going through that. So what happens that all these sensors, they are going to push the data. So the kind of push kind of communication is there. So, or rather one way, because these sensors are having very low compute power. So they are not having full-fledged no kind of operating system, or very basic things are there. So mainly they do what, they sense the physical quantity, they convert that physical quantity into electrical quantity, and then that quantity they push to the gateway. So maybe through digital converter, there might be ADC also, or this gateway device may have ADC, but majority of what you can sensors or the modes that we say, they have their own what you can say ADCs, and then using this flash program, they convert that into it is a digital quantity, and then it is pushed. So here, then this gateway device may be pushing that thing to, in case of our IoE deployment, that is called as no web services. Okay, web services are there, or for example, Amazon AWS IoT core service, AWS IoT core service is there, core is there. So like this is what one thing they do. That is the meaning of this very important thing. They broadcast. Okay, they use broadcast communication, and ad hoc network they use point to point, like your mobile phone device. Your mobile phone device is connected to your base station, and this base station, this mobile phone is connected. So if directly, what you can say, this mobile is having point to point communication with your base station, and through base station there is MTS, through MTS there is other mobile phone device, like this, and then you think that these two mobile phone are communicating, but this is not normal way. In case of your mobile ad hoc networks, what happens that if two devices or two sensors are there, they are having powerful communication system like walkie talkie, and they are having that point to point communication. So when they go in and come out, what you can say, they are having their point to point communication mechanism working in. So mainly for no, that's why this ad hoc network they function, and then this topology or their protocols, it will be used in the what I can say in that network for this periphery. So for the communication, so for example, this device X is there, and you want this device wants to communicate with Y device, then it may use some protocol so that it will use the intermediary to communicate. And similarly, this communication will go on. So like such kind of protocols will be in place, and this device will have their communication acting. Then ad hoc network, they are limited. This wireless sensor network, they are having lots of sensors. Okay, and beyond that, these sensors are very small, and these sensors are having very limited battery power. So because of that thing, we have to use that power very cautiously. Okay, so but in case of your wireless of this mobile ad hoc network, battery limited, this power is not limited. Okay, they are having so comparatively good power because number of nodes in minutes are less as compared to wireless sensor networks. Here you can see, and they went out to have global ID because large amount of I told you that large amount of number of sensors. Global ID is not possible. In case of this mobile ad hoc network, mobile number is one of the example. They have global IDs. So yes, applications of this what you can say WSNs you can see. Monitoring of object, monitoring of area, monitoring of the both area and object. These are the applications. So similarly, now in case of this no IoE sense, what you can say monitoring the object, and in case of specific object comes push that to internet. You have to write the program monitoring of area for specific no pressure, then temperature and air pressure kind of thing. Or sorry, humidity, pressure, temperature, and humidity, and environmental monitoring are both kind of things. So no, and there are many such applications. So for example, now in case of your IoE, your things are there, and beyond that, your people, process, and data. These three comes additionally, and this Internet of Things and people, process, data. It builds IoE. So bigger experience applications are possible. Here, these applications are just no, for example, for the sake of example, but actual smart city applications they are part of this what your IoT or this wireless sensor network. Now, because this wireless sensor networks, we are actually thinking or studying that thing as a part of your IoE deployments. So technically, when we say divide these applications of this IoE are in effect we are considering. Okay. So here you can see this monitoring area can be where this monitoring area can be or what you can monitor. So environmental and habitat monitoring, for example, in case of your this no there are endangered species and animals, so this they are having this caller IDs are there. Or caller what you can say GPS sensors are there rather than caller ID. So this GPS sensors and in full jungle is covered, and then they track using this GPS sensor where this species is moving. So they are monitoring the species, then habitat monitoring, environmental monitoring for no specific air temperature, space, what you can say kind of thing. Precision agriculture. So one of my PhD students, she had this precision agriculture project. So what happens in that precision agriculture? Suppose this is your farm. Suppose I'm spread in 20 acres. So what do you do actually? You take soil samples on specific grid-wise location, and then the soil samples are analyzed not in real time, but at once you have to analyze that thing. Then you find out what is this what I can say type of soil, and then you segment that soil in as per the nutrition, what nutrition contents are there in this soil, and in this nutrition content then you have to decide the what I can say this proportion of your no, nutrient, and specifically for this area rather than giving uniformly to all here this x y z a c that segment clusters are there, you can specify that thing. Beyond that, in then you can monitor how much water using these wireless sensor devices, the soil temperature, soil humidity you can monitor, and then as per that all things can be automated. So clustering is there, then soil content, soil moisture content, your what you can say air moisture content, air temperature, everything. Then how much specific raining has happened, and as per that you can precisely decide what nutrients should be given to that part of soil. And you can think of this as 20 acres, but overall you can think of this thing maybe for a village and kind of thing, and then or for a district, and then accordingly you can go on what you can specifying the nutrient proportion for precision agriculture. Then indoor climate control for greenhouse or other kind of thing. So greenhouse, if you know, so such structures are there. If you have gone, those who are at farmer location, they may know this thing. And in this structure, they have this temperature and everything controlled, and then they have farming inside. So there you have to precisely maintain the temperature, then humidity, and then soil nutrient content, and accordingly you have to manage the overall circuitry and these actuators to closely control this climate. And for that you will need this wireless sensor network IoT deployment. Military surveillance nowadays has become no border lines, fence lines, camera, CCTV, as well as object detection, movement detection. All these things are the treaty verification. If some things are agreed upon, whether this treaty are followed, we can go for the intelligent alarms. So if a specific size of object comes in the vicinity, we fire the alarm. So that kind of things are there. So these are some example of uh, monitoring areas. Yeah. So this precision agriculture I just discussed. Yeah. So monitoring objects when we go for the sensor deployment. So what we monitor? Structural monitoring, ecophysiology, condition-based maintenance, medical diagnostic, urban terrain mapping. So structural monitoring. So if there is a very big bridge is there, okay, like we are having this, Mumbai Worli sea link is there, and it is a very big bridge. So at various these strings, we put this pressure sensors, and then at various locations, stress sensors are there. So what happens that, and then this central, what you can say, monitoring, you are having this graph of at various sensor level. This is one example. Then we are having this our Konkan Railway, and Konkan Railway is no tunnel is there, and this tunnel is very long. And when your train goes into that tunnel, okay, in the tunnel, so what happens that inside this tunnel, oxygen concentration O2 is very important because people are there. So they are having oxygen sensors all over the tunnel. Okay, then there are exhaust. With exhaust, they take the polluted this air out, this smoke out, and they have to act accordingly as the train moves. Accordingly, they have to actuate exhaust at specific locations and take the polluted air out and keep the oxygen sensor air circulating. So for that thing, you need to what you can say go for the structural monitoring. Then that's again example of ecophysiology where how inside this tunnel I maintain specific concentration of air and other thing. Then condition based maintenance. If this is another example of condition based maintenance where in case of your suppose one closed building is there and the temperature and specific gas leakage if we have, then we have to should sense whether it is cooking gas or it is air temperature or it is fire is there, carbon monoxide is increasing. According to that we have to take specific decision. So that kind of object monitoring or area monitoring is there. Medical diagnostic. So we are having sensors which can be put inside the body and then we will measure the blood pressure, heartbeat, then oxygen. Nowadays COVID, because of COVID we had this oxygen concentration level. All these diagnostics can be done using the, and then your smartwatch can monitor that and then it can inform specific cloud service or doctor so that they will take decision based on that patient's health conditions. And urban terrain mapping where GPS kind of mapping what as your object moves. Okay, how this object, very good example of this thing is Google Map. So both it is using satellite image as well as local moving object to specifically map the terrain as well as get the traffic conditions. Okay. So yes, air condition based maintenance. Another example it can be seen here. This fabrication plants. Intel they are having these fabs are there. So fabs they manufacture these chips. VLSI chips are there, and in these chips they need very controlled environment. So the sensor collect the vibration data, monitor wear and tear, report data in real time, and it reduces the team of the number of people which are required to monitor and control the environment. It is reduced. Okay. So between object this we have just discussed wildlife habitat. I discussed disaster management for railway and this bridges, emergency response team, ubiquitous computing. So for large compute deployment, the control of that very big deployment, like in data centers, we are having these sensors and this one thing. And the second thing is that ubiquitous computing meaning is computing which is everywhere. So all these sensors like your smartwatch, your mobile phone, and then your laptop, whatever the smart devices you are having, they are actually giving an example of no that environment where ubiquitous computing is. Every small device is having small compute power, and that device can perform smartly, can act smartly. So asset tracking we have seen, like in RFID tags are used in asset tracking. Healthcare, these wearable sensors are there. Manufacturing process flows, this supply chain management are there. So yes, here you can see this ZebraNet project, collar mounted. I told you this collar mounted GPS sensors, the zebra movement in Kenya. So here this one collar mount can be seen here, and they are using that thing for tracking the movement of that wild animals. Okay, so this the WSNs consist of these sensors, and these sensors are having low power immediate memory and energy constraint due to small size. And in this, we have to actually manage the all the communication aspect of that thing. So that's why here they and deployed in extreme environment, because you may not know where they are, whether this network coverage is there, maybe this 2 kilometer square kilometer, and whether your sensor, so if your network sensor goes out of the network, what to do, how to share the data, how to store the data. So that extreme, or maybe there might be signal may be reflected, signal may not be getting away because of the some trenches or some hills, signal may not be reaching to that what you can say node. Then in that case, how this network will behave, they have to be self organized and self healing. So that's I told you now, if there are 10 network or no, and this what you can say, these nodes are there, suppose these nodes are static, fine, but in this, even in case of static, at given point of two node fail, what will happen? The protocols for the communication purpose, if this network fails, so this should be automatically routed here when the signals are be getting routed to next levels kind of thing. So that self organized and self healing. So if some node fails, some node come in, some node go out in case of moving network, all these things should be handled. That is the requirement of this your wireless sensor network. Then other design challenges are there. I told this can be, I'll show you here. So here you can see about heterogeneity. Okay, here I can see Raspberry Pi on the screen. You can see. Then here I'm having Arduino Uno. Arduino is there, and Node MCU. These three different devices. Maybe I can use these three devices for similar kind of purpose, not the same. Similar means I can connect the BME to all these three things, or this Raspberry Pi can be the edge device, and these two things can be the nodes, and they can communicate. So idea is that heterogeneity. This when you are having 1,000 node MCU, even here you can see this is one node MCU, this is another node MCU, but form factor is different for these two people, because they are coming from different manufacturer and different versions. So all these things I should be able to address. So that is heterogeneity. Then distributed processing, because when certain algorithm need for communication purpose, for calculation purpose, for self-organizing purpose, self-healing purpose, I have to define algorithms which can be okay, which need to be centralized as the processing is carried out, and it should be managing the what is communication or this data transfer over the distributed this deployment also. And low bandwidth communication, because again network issue is will be there, because it will be deployed on very large surface, very large area. So it depending on the available network, we have to go for, so either bandwidth may be available, bandwidth may not be available, channels which are there, because everywhere you may not have this full network connectivity. So accordingly, you must perform very well in low bandwidth. So low bandwidth communication is another design challenge for that. Then large scale coordination, you can see that 1,000 to 10,000 nodes is a typical deployment. So in that case, you should be able to deploy. So these protocols will be studying in this coming lectures. Okay, and for that, for such a large scale communication and coordination, you should have your framework ready. Okay, then utilization of sensors should be utilized, that maximum they should be utilized effectively, and maximum performance is there. For example, the temperature monitoring over the period. So you should have proper plotting of temperature, from which sensor this temperature is coming for a specific district in case of this precision agriculture. So if that optimized utilization of that data is not done, it is a problem. Real time processing, because now many times for disaster recovery kind of thing, this has to be processed in the real time. So you should not, it shouldn't be like that if storm is coming and you are now, your sensors are actually deploying the indicating that thing now, but you take time to process, and tomorrow you tell okay there will be storm in 1 hour, and actually the storm has already happened. It is not like that. So that's why here this real time computation and prediction, sorry for this, we have to AI ML based algorithms or deep learning based algorithms we may deploy at the cloud level, where this data is gathered real time, it is processed. So no stream processing is there, it will be processing, storage, cleaning of data, and in real time we predict that thing using the models that okay there is some anomaly and we have to address the anomaly. So that is the very important aspect, that we must have real time processing and prediction of all the anomaly and adverse conditions which are going to be there. Okay, then what are the other challenges that can be seen on the screen? Energy efficiency, obviously, because every time you cannot go to 1,000 node and charge them. We generally use this small batteries which are either single time use batteries, and we have to replace that thing. So typical battery life should be at least 6 months to 12 month battery life. Then limited storage and computation for the device. We have seen that now generally these nodes, they use the microcontrollers. That the details of these modes will come in the coming slide, maybe next lecture. So they have very less than maybe now this node MCU, it is having less than 2 MB of storage, and then some megahertz of this microcontroller is there. So it is and it is having 3.3 volt input battery, so it uses very less power. That we have to go with that. And low bandwidth and high error rates, because as I told you that it is very large area, and we cannot commission a network which is very well connected to all the network at good bandwidth rate. So that the distance increases, the band what you can say, the loss will be high, error rates will be high, and we have to. So that's why these errors are common: wireless communication, noisy measurement, node failure, because the 10,000 nodes are there, so around 20,000 sensors. So you can see that there is something called as Mtbf, mean time between failure is there. So for so many devices, couple of devices or couple of sensors are failing, and that is very common, and we have to go with that. We have to fill the gap with the algorithms or with the other readings that for that specific reason. Then scalability: initially you may deploy your network with 1,000 sensors, and then you say that okay, now things are working and I will be going to 10,000 sensors. 10,000 sensors, so that scalability, 10 times scalability now it is expected here, and we are talking about that. So yeah, large number of sensor node, it should be possible with your algorithms and deployment. And survivability in harsh condition, we have seen that thing, because these sensors are in open space, air, then raining is there, hot sunlight is there, and all this is kind of delicate device is there. Again, another that sensor photograph will see. So we cannot keep this thing. So we have to proper covering, and then maybe we have to moisture, then the dust, everything we have to design or take this sensor so that they are actually performing in this harsh environment, and they should have a good life into that. Okay, because you cannot replace 1,000 or 10,000 sensor every 4 1 5 months. Okay, and exponents are time and space incentive, because when you want to deal and read data and deploy 10,000 sensors, so it takes time, and again to run the program, check the error, then run the algorithm, all these things are time and space incentive. So these are all challenges of your IoE. Also it is, we have seen here wireless sensor network, same applies for IoE. Okay, yeah. So yes, these are the enabling technologies means what? The technologies which push the things. So number of, what you can say, when we say that now this IoT here, you can, I told you that when I was doing my masters, such sensors could cost around 10,000 rupees or 20,000 rupees as a whole. We have seen that thing. I will show the pictures also. But nowadays these things are costing you some few hundred rupees, or in dollars, $1 or $2 kind of thing. So that's why this embedded device, these are the systems which are having VLS and embedded device. So they are very common with having, they are having wireless and internet connectivity. So embedded device, network device, here they are possible. Then sensing, now this device has got onboard ADC, then digital line, analog lines are there, and then small and powerful sensors are available. I told you, I shown you this BME280. So this compact sensor is there, sensor size is very small, power consumption capacity of this sensor is very small. So here, and they are cheap also, around 300 rupees you get this BME280. This is ultrasound sensor, distance sensor is there. So these sensors, because of this, again, no, very small and powerful, energy efficient ultrasonic devices, you are able to, yeah, BME280 can be seen, very small sensor can be connected to this, to it, this node MCU, and they can work together. So yeah, they are enabling technologies. So embedded things are easily available. The sensors are no tightly coupled. They are available, cheap, and connectivity is there. Okay, and networking possibilities, because now this is very important for internet of then things. This things part is done, taken care here and here, sensing part. Okay, so then again it's a small form factor, then costing. This is another enabling technology. Nowadays we are having cheap sensors, then protocols which are there developed by then cloud technologies. Cloud backbone is available to you. Because of that thing, it is very easy to deploy. Like Heroku is free of cost, AWS now available for students. So all these technology are enabling the IoT deployments. Yeah. So future of WSN. So here this WSN is there, but we can say actually future of WSN is IoE. Okay. So smart home, smart office, I can say here smart cities also. So sensors controlling appliances and electrical devices in house, smart home, some of you are having project, better lighting and heating in office, smart office project, then smart agriculture, precision agriculture. So here you can see this Pentagon buildings. This is one here, US building is there. Very, it is like a fortress, digital fortress, very secure building, and they are having this building smartly controlled by all these kind of aspects of your wireless sensor network or IoE deployments. Yeah. So here the another thing can be seen, this Retina processor chip. So now we can, this is a sensor which can sense the real life data. So like it, maybe these blind people, they will be benefiting of this thing. And then your heart rate, your body sensors are there, you're using, they are, doctors are using to monitor your vitals if the patient is has had gone the critical medical procedure, so that will help. So this is another applications. So tactical monitoring, we have seen that urban terrain mapping, and then how through the specific in you can also deploy this sensor on your fence or on your protected area where you can track the movement of object, or how to know how many people, how many soldiers are moving through that terrain. That can be military applications of that thing. Industrial and commercial applications of this WSNs are precision agriculture, inventory tracking, in-process parts tracking, automated problem reporting for certain deployment. You are now, this example is very good. Is this no Boeing? One typical aircraft, it has got 24,000 to 30,000 sensor or more nowadays. So these sensors are connected to central computer to monitor this, no, what is the aircraft condition. Even your this no Formula One racing, they are having these sensors all over your car, and they remotely monitor your car, and in real time they track the problem. And RFID theft deterrent, customer tracing, then automated toll collection, then plant equipment and maintenance, like in the Pinoles industry, this whole plant is having these sensors, and they have this central monitoring of these various process and process flows. In traffic management and monitoring, so one example of this traffic management, not but monitoring, is Google Maps, where this traffic is real time traffic data is there, and on the map you see what is happening with this a bit. Okay, so we stop here. Next time we'll see the modes. Okay, actually what modes are there? Modes are actually your WSN nodes. This is no, I don't say very old concept, but old concept, because in IoE you won't see modes. You just see that nodes. You see that nodes, and old, what you can say, name for these modes are, these nodes are modes. That time they this device is no one single device which is capable of having sensors, then battery, then power, and then communication. It is called as mode. And then maybe depending on your application, you can customize the sensors which are connected to this thing, and it will function. And such hundreds and thousands of modes are deployed in WSNs, or if we are thinking of your IoE deployment, so they are deployed as a part of your IoE deployment. From this part, we'll start tomorrow. Here I'll just show you that picture. Yeah, yeah, you can see this Telos mode. But nowadays, what we use, use this Arduino, or we use the same thing. Here you can see this Node MCU, same, and they are much powerful as compared to these modes. These modes. Okay, nowadays you can build your own custom, what you can say, mode using Node MCU or Raspberry Pi also, much powerful also, and much cheaper also. Okay, so we'll see this thing in the next lecture. Okay. Just a minute. Let me stop the broadcast.